Now let's look at the piston machining detail. And this piston is set to work in a 1/2 inch pipe piston tube. And we're making the piston out of stainless steel rod, 5/8 diameter. 5/8 is 0.625, which is just a little more than that. So we'll be able to machine it down. 12 inches long. And so I'm going to cut it into about 11 pieces. And type 304 stainless steel. So that's what we're going to make it out of. Here's our inspection criteria. Again, we're going to inspect 100% of the parts for these critical dimensions. We're going to deburr and chamfer the lead in. Chamfer the lead in. This is a lead in, and this is a lead in. And this is our standard tolerances. So let's take a look and see. I've made a top view as my primary view. I've cut a section of it so that I can see it. And I've got it isometric so that you can see it also. Now, as we do this, this is a very important diameter, this 0.589, because that came out of my O-ring design catalog of what will fit inside. And so that's a very, very critical dimension. So I'm saying I can't go by just this stuff. I'm saying that I want 3 decimal places there, and I want no worse than 0.587 inches. That's a very tight tolerance. It can be done. It's a little bit more expensive than normal, but it can be done. But that way this whole thing will fit in there well and it'll look good. Not every place does it that way. We can talk more about improvements as we go along, but that's a very good dimensional call out. Okay, now the inside, this is where the spring is going to sit. This is going to push it back up when we release the air. So I'll be able to put in a 0.43 diameter spring because this is plus or minus 10 thousandths of an inch, which means that this can be 0.434 to 0.454. Okay, so that lets me know about this, and that's not a huge significant tolerance. And this says that it goes 0.75 inches deep. Okay, so that helps me understand what my spring is going to be like. And it's a pretty tight tolerance, but not terribly. But now I've got where the O-ring is going to sit. That's this dimension right here. And I put the little diameter symbol in front of it because this is a diameter and nobody would know unless I put the diameter symbol in front of it. And that was another one that was very, very critical in the O-ring book. So 0.504 plus 0 minus 2 thousandths of an inch. And then the thickness of it, the O-ring groove, I looked it up and I can be 0.098 and I can go plus or minus 10 thousandths of an inch. So all of these are 3 decimal places, and these 2 are a little bit more critical. And of course, I'm going to inspect all of these. Now, these length dimensions here, who cares where that O-ring is? It can be anywhere along here. So I've used these ones at very uncritical dimensions, 2 decimal places, so I don't waste too much time and energy trying to get that perfect. So that's how I'm going to do that. And then this just gets filled out. You're going to have to do this. So you're getting used to, I hope, how to do all these. Let's take a look and see what that looks like. Oh, and by the way, 304 stainless steel rod, I looked at 5/8 and lo and behold, I can find 5/8 rod that's 12 inches long. I can get even better. It's $13. So each one of these pistons is going to cost me a little over $1 worth of material. And if I make it longer, it gets cheaper because I get a better deal. Okay, so I went and looked that up. Let's come back over here and look at my piston. So here's my piston drawing. And so again, I started with my main top view drawing, and then I put in a section view, another section, a projection of my section view. If you look up here, what I did is I edited the sheet when I made it to make it a B-size sheet, landscape, and I put the ANSI A size on. Not the large, but the ANSI A size. So I had to get rid of what was there and add this one. And when I come into my field text, I go to a blank one, edit, and in my summary, I've got again machining detail, the ESGN 330. Under my project, I've got my part number, which should come down, but I think I had to edit that a little bit. And I've got my revision A. Okay. And the scale comes in automatically, whatever you bring this one in at. Okay. I brought in my parts list. I just clicked parts list and it brought all that in. And then I needed to type in my stainless steel rod. I brought in my revision block and I got all that. And I wrote in revision A and new release. I copied these from one that I already had. I just copied. And then it's into the drawing. And I copied this one too. Okay, I just copied that and put it in there. So that's how I got all that. Now let's see how we work with these kind of odd dimensions. So if I click on the dimension, I can edit it. Edit. That's what I usually do because it brings me up to this. It's the easiest way. And so I changed it to 3 decimal places and 3 decimal places. And then I picked something called deviation. How far does my tolerance go above my standard unit and below? How far does it deviate? And when I do deviation, I can put a different number in. So I'm just doing what the engineer said, +0 -2. So it can deviate +0 on the upper side and -2 on the lower side. And I can just type in whatever I want. That's how I got those. And and one other thing I had to do when I did my edit and I went into the text, I wanted to make sure if it did not have that, this one had it already because it was a diameter, has the diameter on it. Now let's take a look at this one. Oh, and this one, let's look at that. That one is a hole. Okay, so I had to click. If it didn't have the depth thing, I had to click it. Okay, sometimes the hole does not have the depth. So I had to click on it. These are mostly just click and edit. Right click, edit. This one, since it doesn't know it's a diameter because I'm in a linear dimension view, I had to go to the front and type in the diameter symbol. And that's critical. Otherwise, somebody doesn't know it's a diameter. Okay, and then on my precision and tolerance, I did the same thing here. So that really, I think, should give you enough. I copy and pasted that. This one I just set. I set. Just edit. Make sure it says 2, 2. I think that gives you enough info. Oh, you know what? As I'm looking at this one, that one should have a center line on it. Shame on me. That should have a center line. Center line, click. And this should have a center line. Center line, click the 2 lines, and it puts a center line in for me. Okay, so those should be added. Please add those center lines. You don't need one over here. If you want to, I'm not sure if it really does one. It did. That's amazing. That's really cool. That's really hard to do in AutoCAD, but you can do that here. That's really nice. Wow, I learned something new every day. Cool. There we go. That's how you do the piston.